I'm Mayank. I'm one of the co-developers of this project alongside Arthav, Neel, and Aryaman. Our project is the ElectroMag simulator, a simulation app that allows you to place a charge of either positive or negative value and watch as how it moves and influences the electric and magnetic fields, both of which we can visualize within the simulator. So let's go ahead and take a look. We start out with our grid. This is where we can place the charges of either positive and negative value, and we have our charge controls. This is where we can set the charge value, the speed of the charge, and, and allow us to see the fields and control time. For now, let's turn many of these settings off and take a look at the charge value. This is measured in coulombs, and currently it has a positive value. So we can go ahead and place ourselves a positive value of a charge. Do not be mistaken, though, this is not really a proton. The protons actually have a much smaller charge compared to this. In fact, a proton charge has approximately 1.6 times 10 to the power of minus 19 coulombs, which is way smaller than this can properly simulate. In addition, we also have its charge speed, which is 115 meters per second, though it doesn't actually seem to move that fast as in the grid. In addition, we also have our negative charges, and we can place that right away. And what this does here is that it simulates our fields as well. You can take a look at the electric field here. This here is the electric field. It is governed by Gauss's law, Faraday's law, and Ampere-Maxwell's law. Gauss's law states electric charges create electric fields, as you can see here. Faraday's law states that a changing magnetic field creates an electric field, and Ampere-Maxwell's law states that electric currents and changing electric fields can create magnetic fields. Next, we can also show our magnetic field. The magnetic field is governed by Gauss's law for magnetism and once again Faraday's law and Ampere-Maxwell's law. Gauss's law for magnetism also states that magnetic fields always create closed loops. You can see this with this field here. You can see how the vectors are always pointing towards the end, towards this end point here when starting from here, and the reverse for the opposite side. Now let's see what happens when we actually start time. As you can see, they accelerate towards each other. And if we take a look at electric fields, we can see that they both interact and they alter the magnetic and electric fields. And what we can also use is we can also put in more charges. Let's add like 5 more protons and 5 more electrons. Though, like I said before, these aren't really protons or electrons. Like the amount of charge they have is way smaller. And you can also start to see that they're starting to form some pretty beautiful patterns. Let's add a lot more and see how that goes. This here allows us to simulate particles free flowing. This looks quite similar to also Brownian motion, though it's not really Brownian motion because we don't really have any actual atoms or compounds. These are mostly just charges that are being attracted to each other by the electromagnetic force. Now you might ask, why is this important? Why simulate electric and magnetic fields? Well, for one, the most obvious answer would just simply be education. Being able to teach you about electromagnetism requires comprehending electric and magnetic fields, something that's really hard to do alone and in words. And for visual readers, this is much more difficult. However, with electric simulators like this, you can simulate the electric fields, and you can also simulate magnetic fields as an electromagnetism simulator would do. And this makes it much easier for students to analyze these fields and see how they interact with different charges. And another big reason is just for enjoyment. Being able to simulate electric current and electric fields along with magnetic fields, those can be very helpful. As such, all these three make it very useful to have an electromagnetism simulator, and especially the education topic, as it will help students a lot in applying these principles into the real world and when building electrical circuits. Thank you so much for watching this.